Try this. Imagine sitting in a room where nothing is technically wrong. The walls are intact, the windows are closed, there are no gaps you can see, and yet you feel it. The environment isn't helping you anymore. Every bit of warmth you create disappears faster than it should. The space doesn't hold anything. It doesn't respond. It just takes. You move closer to the heat. You add more. Doesn't matter. It fades, like pouring water into something that can't contain it. And that's when it becomes unsettling. Because the problem isn't outside, it's the system you're inside, a system you assumed was stable, but was actually being held together by something you never noticed, something constant, something invisible, until it stopped. The instinct is to fight it, to add more heat, to close more gaps, to push back against whatever is taking it away. But none of that works, because the problem isn't how much energy you create, it's how long it stays. And that changes everything, because once you see it that way, you stop asking, how do I make this space warmer? And you start asking something else. How do I stop this space from losing what I already have? Now, imagine living in a place where this wasn't a temporary failure, but a permanent condition. A place where the environment doesn't just challenge you, it strips everything away constantly. Not for hours, not for days, but for months. In the northern plains of ancient China, winter wasn't a season. It was a system. 5 months of exposure, 5 months of instability. 5 months where nothing you created could last on its own. And here's what made it worse. Fuel, the one thing you would rely on, wasn't available. Not because it didn't exist, but because you couldn't use it. Wood was controlled, reserved, too valuable to burn for survival. So the usual solution, just make a bigger fire, was never an option. You could generate heat, but only in short bursts, and every time you did, you were spending something you couldn't easily replace. That meant one thing. You couldn't rely on continuous input. You couldn't depend on something that had to keep running, because eventually, it would stop. So instead of building a life that required constant energy, these villages built something else, a system that could hold energy longer than the environment could take it away. Not one idea, not one invention, but multiple layers, each solving a different failure point. Because the problem wasn't just heat, it was everything connected to it. If you solved warmth but not airflow, you suffocated. If you sealed the structure but lost light, you broke mentally. If you survived the cold but lost nutrition, your body failed anyway. So the solution couldn't be simple. It had to be complete. And that's where everything changes. Because what they built wasn't a house. It was a system designed to remain stable, even when everything around it wasn't. And once you understand that, you stop seeing these as old techniques and start seeing them as something else entirely. Not history, but answers to a problem we still haven't solved. Most people think warmth comes from fire. That's the assumption. You light something, it burns, it produces heat, and as long as the fire continues, you stay warm. But there's a flaw in that logic. Fire is fast, it releases energy quickly, and then disappears just as quickly, which means if your survival depends on fire, you are forced into a constant cycle. Feed it, maintain it, watch it, repeat, and the moment you stop, the system collapses. That's not stability, that's dependence. The villagers understood this at a deeper level. They didn't try to make weak fuel behave like strong fuel. They changed the role of fire completely. Instead of using fire to heat the air, they used it to charge something else, something slower, something that didn't react immediately, a structure, solid, dense, unresponsive to short-term change. When a brief burst of fire moved through it, the energy didn't vanish into the room. It was absorbed, stored inside the material itself. And that's where the shift happens. Because once heat is inside mass, it stops behaving like a flame. It becomes delayed, controlled, predictable. Hours later, long after the fire is gone, that stored energy begins to return. Not all at once, but gradually, exactly when it's needed most. At night, when the environment drops to its lowest point. This reverses the entire system. Instead of constantly feeding a fire to survive, you invest a small amount of energy once and let the structure handle the rest. What looks like a simple platform becomes something else entirely, a thermal reserve, a buffer between you and an environment that never stops taking. And once you understand that, you start to realize something important. The fire was never the solution. It was just the trigger. Heat doesn't disappear randomly. It leaves through structure, not through the obvious parts, but through the ones you don't notice. Tiny weaknesses, microscopic gaps, imperfections that seem irrelevant until the environment finds them. And once it does, it doesn't stop. Cold expands, moisture freezes, materials shift. What was once solid becomes fragile, and slowly, your shelter stops acting like a barrier and starts acting like a filter, letting everything pass through. So the problem wasn't building walls, it was stopping walls from becoming something else. Because in that environment, every structure is temporary unless you actively resist the process that breaks it down. The villagers didn't approach this like builders, they approached it like observers. They paid attention to how materials changed under pressure. What weakened, what held, what transformed, and instead of using materials that stayed the same, they used materials that improved under stress, that bonded tighter when exposed to the conditions around them, not by accident, but by repetition, season after season, until the wall wasn't just a structure, it became a response, a surface that adapted to the environment pressing against it. And once that happened, the invisible leaks stopped. Not completely, but enough to shift the balance, from losing heat constantly to holding it just long enough to matter. Most designs are defensive. They try to block, resist, and isolate, but force doesn't disappear just because you ignore it. Wind doesn't stop because a wall is in the way. It builds, it presses, it looks for weakness, and if it finds one, it exploits it instantly. So the instinct is to reinforce everything, make it stronger, thicker, more resistant. But that approach has limits, because eventually, the force becomes greater than what you can resist, and when that happens, everything fails at once. The villagers chose a different approach. Instead of resisting pressure, they redirected it. They positioned materials so that force didn't weaken the system. It stabilized it, so when the wind increased, the structure didn't struggle. It tightened. Every gust became reinforcement. Every surge became support. And that changes the entire equation. Because now, the environment isn't something you defend against. It's something you integrate, something that actively helps the system hold together. And once you do that, you're no longer fighting instability. You're using it. A perfect seal sounds ideal. No air, no gaps, no loss. But perfection creates a new problem, because what stays inside isn't always harmless. Every system produces byproducts, things you don't see, don't smell, don't notice until they accumulate. And once they do, the space that protects you becomes the thing that harms you. So the goal couldn't be complete isolation, it had to be balance. A system that allowed movement, but controlled it. Not enough to disrupt stability, but enough to prevent collapse from within. This required precision. Not mechanical precision, but learned precision. Understanding how materials behave when layered, how air moves when restricted, how much is too much, and how little is too little, because in that narrow space between exposure and suffocation is where survival exists, not in extremes, but in control. Food is temporary. It spoils, breaks down, disappears. But what the body needs isn't food itself. It's what food provides, the invisible components, the elements that keep systems running. And when those disappear, it doesn't matter how much you eat. The body begins to fail anyway, slowly, from the inside. So the challenge wasn't storage, it was preservation of function, keeping those invisible elements intact long after the original form had changed. And that required a shift in thinking. Instead of trying to keep food the same, they allowed it to transform, under controlled conditions, where time didn't destroy it, but stabilized it, converted it into something more durable, something that could last through months of absence. Because in an environment where nothing grows, you're not storing food, you're storing continuity, the ability for the body to keep functioning when everything external has stopped. We experience the world at the surface, where everything changes, temperature shifts, conditions fluctuate, extremes define reality. But that's only one layer. Below that, everything slows down, variations decrease, stability increases. The deeper you go, the less the environment changes. And at a certain point, it stops changing almost entirely. That's where the villagers moved their most important resources, not upward, not outward, but downward, into a layer where instability no longer applied. Because sometimes, you don't solve a problem by resisting it. You solve it by stepping outside the system that creates it. And once you do, what was once extreme becomes irrelevant. There's one part of the system that modern design avoids because it's unpredictable, inconsistent, difficult to control. People, individually, the human body is inefficient. It constantly loses heat, constantly consumes energy, constantly requires input. But collectively, something changes. Loss slows down, efficiency increases. Stability emerges not from structure, but from proximity. Each individual becomes part of a larger system, where output is shared, where loss is reduced, where the group functions as a single unit. Not by design, but by necessity. Because when resources are limited, separation becomes expensive. Isolation becomes dangerous. And the idea of individual comfort no longer makes sense. So the system adapts, not around objects, but around people. And in doing so, it becomes more efficient than anything built alone. We tend to measure progress by what we add. More power, more control, more output. But there's another way to measure it, by what still works when everything else stops. Because most modern systems depend on continuity. They need constant input, constant support, constant maintenance. Remove that, and they fail almost immediately. What these villages built worked differently, not because it was more advanced, but because it didn't rely on anything continuous. It stored energy, balanced flow, adapted to pressure, used what was available, and most importantly, it kept working even when the environment was actively working against it. That's not just survival, that's design. And it raises a question we don't ask often enough. If the systems we depend on today stopped, how many of them would keep working? Because this isn't just about the past, it's about something we're starting to rediscover. Not by choice, but because we're beginning to see the limits of the systems we built. And in the next video, we're going to break down another system that was designed to work without constant input. One that modern engineering is only now starting to understand again.